Hello students, welcome to Akshar IIT Foundation classes. This is Ghaffar Muhammad, your physics faculty. Let's start our session. So in the last class we completed about differentiation, isn't it? And also we have seen that some problems related to differentiation, and also I have given some important formulas related to differentiation. So the thing is, today our topic is integration. So what is integration? What is the formulas for integration? And some questions we'll do in today's class. So let's start writing the formulas and attempt the questions, isn't it? So first of all, let me introduce what is meant by integration. Better write down integration. Integration. What? Integration. This is our topic. What is integration? See here, you know already differentiation meaning. Differentiation meaning is nothing but finding the very small value of the function. Understand, children? Finding the very small value of the function is nothing but differentiation. Now what about the integration? The integration is nothing but exactly opposite operation. Understand? So here differentiation is nothing but finding the very small value. But what is this integration? The integration is nothing but adding the all small values. Understand? Adding the all small values. If you add all small values, very infinitesimally small values, we add, what you will get? You will get a big value. So that is meaning of the integration process. Got my point? So let's see. So there is a no requirement of the proofs and all the things. Only how to apply the formulas, how to use the formulas is enough for according to physics point of view. Understand, children? So now I'll show how to add, how to get it. Look at here. First of all, let me take a length I am taking. So this is let us take this is point x0 point, and this is xi point. Understand? So this is something length. I am giving some example here how to take the differentiation. So in this length, here first initial point of length is x0, the final point of length is xi. Now look at here. So actually this is the length, right? So here in this length, let us find very small value. Finding the very small value is nothing but what? Differentiation, right? So this is a small value. That small value you can take as a dx. Very, very small value. The small part of the length I am taking dx. To find that small point, small part is nothing but differentiation. Now what is mean by integration? Integration is nothing but adding these small points. Adding these small points. Here how many small points you can divide? You can divide n number of small parts, right? So all the n number of small parts if you add, the process is nothing but what? Differentiation. But you will add these small parts from where to where? From x0 to x. Here this x0 and xi nothing but the limits of the integration. Understand, children? So what is this here? You are adding this. You can convert this whole length as a n parts, n small parts, right? But if you add that such n small parts is nothing but integration. But adding from where to where? Adding from this x0 to xi. Here this x0 and xi are called limits. Now here already you know, in mathematics, this is telling that this is nothing but plus symbol, okay, symbol for this. By using this we can add the two numbers, right? So what is this minus sign? The minus sign is indicating that by using this operator you can subtract two digits or two numbers, and This is called multiplication. By using this you can multiply two numbers. At the same time, by using this operator you can divide two numbers. Similar way, by using this d by dx, what you will do? You will find a very infinitesimally small value for the function. So this is nothing but operator. So plus is a symbol, operator symbol for addition. Minus is a operator symbol for subtraction. This is called cross symbol. Cross symbol is for operator for what? Multiplication. And this is division symbol. It is for divide two numbers. And this is a operator for finding the very small value. Now, what is the operator for integration? Yes, the operator symbol for integration is integral dx. So what is that? Integral dx. This what somewhat it looks like a snake, right? Isn't it? But it is not snake. It is what? A symbol. It is an operator for what? Adding the function. Okay, it is an operator for what? Adding the function. Got it? So here this combinedly called operator. So by using this operator, we can add very little small elements or little functions, isn't it? I'll give one example. So here we have a function. I'm taking the symbol how to use this operator. Look at here. I'm taking a function f of x. What is the function? F of x. Now I wish to do integration for this f of x. So now for that, how to write this, how to use this symbol here, you will take integral f of x into dx, f of x into dx. That is the symbol for what? Integration. But you are adding the small elements, right? Integration nothing but adding the small elements from where to where, from limit, between the limits. Where you will write that limits, you will represent the limits, initial limit to final limit. Okay, initial limit to final limit. So sometimes we call it is a, this is called lower limit, this is called upper limit. From lower limit to upper limit, if you add the functions, add the small infinitesimally small values, you will get a big value. The process is called integration. So this is your what? Symbol for integration. Now if you do this way, what you will get finally? Some other function g of x. Some other function g of x. This g of x represents whole value of that in addition of n number of small infinitesimally small parts. Understand, children? This is about your what? This is about your integration. See, in this integration, what is the symbol? Integral f of x dx. This is the way you have to express the function. Understand? So now here what will you do? Let's first explain the formulas. Later we'll do some problems based on the formulas, isn't it? So now I'll go for next slide. Better write down. So our topic is what? Integration. I think you got it. Now I'll go for next slide. So now take the formulas for integration. You know, in the differentiation, d by dx of x power n formula. D by dx of x power n formula you know very well, that is n into x power n minus 1 is a formula. Similar manner, in the integration also, we have integration x power n formula, that is a fundamental formula. So what is that? Integral x power n dx. So I am taking the limits from where to where? The limits from x1 to x2 I am taking. So this is your what? This is your x power n formula. Once a minute, I am not taking limits here. I'll say why I am not taking limits. Integral x power n dx. That integral x power n dx is x power n plus 1 by n plus 1, okay, plus C. This is your formula for what? Integration. See, why I am adding the plus C? What is the reason? I'll say now. Look at here. Look at here. See, I'll take the one example. After the example, I'll explain why I'm taking here. So now I'll take a simple example here, how we are using this formula. Now, see, example number 1. I'm taking very simple example, x power cube different integration. X power cube integration. What's supposed to do here? Here x is as it is, you have to use this formula, this basic formula. What is the basic formula? X power n dx. X power cube, here instead of x is here x, we have also x, and instead of n what we have 3, means power is 3. So you can take n as a 3. So in that way, x power 3 plus 1 by 3 plus 1 plus c. So this is become x power 4 by 4 plus c. So this is the integration x cube dx value. Integration x cube dx value. So now I'll give one more example here. One more example. Look at here, one more example. The example is integral x power 2. Integral x power 2 dx is equal to same formula. Here power is how much here? N value 2. So use that n value x power 2 plus x power 2 plus 1 by 2 plus 1 plus c. So finally what is the answer? X cube by 3 plus c. So this is your integration value. But why I am writing the constant? Actually this c is nothing but a constant. See here, actually we have two types of the integration, So first type is, see, the first type is indefinite integration. Indefinite integration. What is the first type? Indefinite integration. And the second type is, type 2 is definite integration. What is a definite integration? So you might have confusion between what is this indefinite and what is definite. Look at here. Without taking the limits, if you do different integration, without taking the limits, if you do integration, that is known as indefinite integration. In the indefinite integration, after integration, you must add a constant. So simple logic, simple thing. So once again I am telling, indefinite integration means without having limits. When you are not having the limits, after integration process, you must add a constant for the final equation or final result. So what's supposed to do here finally? For indefinite integration, you must add a constant for final result. This is for indefinite integration. Now definite integration. What is this definite integration? So integrating the function within the limits by using the limits is known as indefinite integration. So see here, definite indefinite integrations, both are formulas are same. Only the difference is final result if you must add a constant for indefinite integration. Now in the definite integration, there is no requirement of the adding a constant value for what? For final result. I'll give an example for having the better idea. So now I'll give the example. The example is, let's take integral x power 4 dx, and same integral, this is one example, so this is example 2, integral x power 4 dx, but limits are 1 to some 3, let me take 1 to 3. Now when you are doing this integration, you have to use basic formula. The basic formula, what is the basic formula here? Basic formula is integral x power n dx. In that case, what is the value here? X power n plus 1 by n plus 1 is the value, isn't it? Now the same formula you can use here. Integral x power 4 dx is equal to x power 4 dx is equal to, so what is we will get? X power 4 plus 1 by 4 plus 1, so plus c you must add because there is no limits. So now the formula become x power 5 by 5 plus c. This is your integration power 4 dx. Now what is this? Here also you must use the same formula. What is that same formula? Integral x power n dx is equal to x power n plus 1 by n plus 1. X power n plus 1 by n plus 1. This is your formula, but you are taking the limits x1 to x2. Here also you must take limits x1 to x2. So finally, after having the limits, you must apply the limits here. How do you apply the limits? I am applying. You can take n plus 1 outside. So first apply upper limit. If you apply upper limit x2 n plus 1 minus apply lower limit x1 n plus 1. So this is the way you must apply the limits after having the integration. Here no need to apply directly, you will get answer, but you just add the constant. Here there is a no adding the constant, just you need to apply the limits. Now I'll apply these limits for this integration. Now you know x power 4 integration is x power 4 plus 1 by 4 plus 1, but limits are from where to where? Here 1 to 3, so 1 to 3. Now apply limits. How do you apply limits? First you can take this 4 plus 1 common out. If you take 4 plus 1 outside, that is 1 by 5. First apply upper limit. Upper limit is 3. But where you apply this upper limit? You apply upper limit instead of x. So instead of x means 3 power 5, isn't it? 3 power 5 minus 3 power minus next lower limit. Lower limit is how much? 1. And instead of x you need to apply 1 here. So 1 power 5. So now simplify it. So better note down. So this is the way you will apply the formulas. I'll give one more. Don't get worried. I'll give one more example here. The one more example I'll take in the next slide. So now, yeah, I'll take one more example here. Integral x power 7, or simple way you can take integral x dx. Integral x dx. Now this is one. I will take one more integral x dx, but the limits are 2 to 4. This is your integration. So now, which means here they are asking indefinite integration. Here they are asking definite integration. Indefinite integration, what's supposed to do? Final result, you must add a constant. Definite integration, you must apply limits. That is the basic difference. Now, here what is the formula you will use? Here you will use the formula integral x power n dx formula only. then that is equal to x power n plus 1. Yeah, now, so we are taking the two examples here. The example number 1 is integral dx, integral x dx. The example number 2 is integral x dx. Here, this is indicating that definite integration, this is indicating that indefinite integration. So now how these two will be solved, let's see here. So the basic formula is integral x power n dx x power n plus 1 by n plus 1 is our basic formula. Now here, see, now I am applying the formula. When you apply the formula, see here, integral x dx is equal to, so here x power is how much here? X power 1 plus 1, x power 1 plus 1 by 1 plus 1, because something is not there means what? How much value? 1. So that is nothing but x power 1. X power 1 or x, simply x is the remains the same. So now power 1 means 1 plus 1 by 1 plus 1. So the value, now you must add a constant here. So finally it will become x square by 2 plus c. So this is your integration. This is called indefinite integration. This is called what? Indefinite integration. Coming to the definite integration. Same formula you use. Integral 2 to 4 x dx is equal to integral 1 plus 1 by 1 plus 1. Limits you can take as it is 2 to 4. Now here you can take this 1 plus 1 common out. Now I will apply upper limit first. If you apply upper limit, where you apply upper limits here? The upper limit apply instead of x. So what is x here now? 4. 4 square minus. After applying upper limit, you must subtract minus lower limit. Lower limit is how much? 2. Where you apply this 2 instead of x. So 2 power 2. So finally 1 by 2, 4 square is 60, minus 2 square is 4. So now 1 by 2, 16 minus 4 is 12. So 2 1s are 2 6s are. 2 1s are 2 6s are. So finally this value is 6. So there is a no adding the constant because already we apply the limits. But here we don't have limits, since we need to add some constant value. The constant value you can take C here. So this is the way we'll do the indefinite, definite integrations. I hope you understood this. Now I'll give some other formulas related to integration, and also we'll do some problems based on that. See, now the formulas are the first formula and second formula, important formulas. IMP formulas, important formulas. First one is integral C dx. Integral C dx. So integral C dx is C here, C is a constant, then value is Cx plus Cx plus something like a constant k, Cx plus k, because I am not taking any limits here, so that you must add constant. Here C and k are what? Constant. This is one formula. So simply what is the meaning here? Integration of constant. Integration of constant is how much? C into x plus c. When you are taking the limits, no need to take this k. And similar way, let's take one more formula related to trigonometry function, that is sine function. So that is integral sine theta sin theta or sin x dx, which is equal to minus cos x plus c, minus cos x plus c, this one and this one. Very important formulas. Now let's do, based on these two formulas, let's do some questions. The questions are, first I'll take question based on integral c dx. Now example, what is the example? Integral 2 dx, integral 2 dx. Here 2 is a constant, right? When 2 is a constant, how to integrate here? The integration, you can use this formula. The formula you can write as 2 into x plus c. So this is your answer for what? Integration for constant. Similar way, integral sin x you can use directly, not required. Now I'll take one more example here. The one more example is integration of x square plus 1 dx. This is a function I have given. This is a function I have given. When this kind of function, how to solve? You can solve this kind of function. So first of all, apply operator for both terms. Here how many terms we have in this function? 1 and 2. 2 terms we have. Now first apply this operator for both terms. Now I am applying the operator. Operator is integral. Integral operator I am applying for both terms. Integral 1 dx. I have applied for both terms. Next, and this x square, integration x square is like a general formula, right? Then if I apply general formula, it become what? X power 2 plus 1 by 2 plus 1 plus integral 1 dx. Here 1 is a constant. Constant integration is what? C into x, means 1 into x. So finally what you will get here? X only. Now after doing the integration, you must keep a constant. Why you must keep a constant? You had some constant because this is indefinite integration. Now finally what is the equation? It is become x square by, x cube, right? X cube by 3 plus x plus c is our answer. This is the way we will solve the integration problems. Now I'll give one more question. So the one more question is one more example. Integral x plus sin x dx. Integral x plus sin x. This is some example. Now how do you solve this example? So first of all, you have to apply the operator for both terms, because here how many terms we have? 2 terms. You can apply the operator for 2 terms. Now integral x dx is one term. Integral sin x dx is one term. You know integral x dx. X dx you can write as by applying the general formula. Now I am applying the general formula, x plus 1 plus 1 by 1 plus 1 plus sin x integration is minus cos x plus c. Finally the answer is x square by 2 minus cos x plus c. So this is the way you have to do the problems. Now I'll give one question to you. The question is, so you can open page number 18 from your material. So that is first question. So look at here the first question. The first question they are given as integral cos x dx. Actually I did not say integral cos x dx. You know, integral sin x value is cos x, right? Minus cos x. But here cos x integration is simply sin x, opposite to it. So the limits also they mentioned 0 to pi by 2. So first, which means that this is definite indefinite integration. This is definitely, it is definite integration. Now first, apply limits, integrate it. First integrate it. Now integration cos x is nothing but sin x. Limits are what? 0 to pi by 2. Now first apply upper limit instead of x, sin pi by 2 minus sin 0. I have applied upper limit minus lower limit. When I apply upper limit, sin pi by 2 value is, 1 sin pi by 2. Sin pi by 2 is nothing but 90 degrees. Sin 90 degrees is nothing but 1 minus sin 0 value is 0. So finally the answer is what? 1. So what is the option here? You can check the option. So answer is what? 1. So that is second option. That is second option. Similar way, do 2x minus x cube. 2x minus x cube. So one more question. Integral 2x minus x cube into dx. This is your question. Now the limits are 0 to some r. 0 to some r. Now first apply integral 2x dx minus integral x cube dx. So applying the limits here. Applying the limits. So now you can solve here integral 2x means 2x square by 2 minus x power 4 by 4. Limits are from where to where? 0 to r. So this is the way. Now you can apply limits. It will become here 2 cancel. So r square, okay, instead of x you need to apply r minus r power 4 by 4. This is upper limit minus lower limit of you apply, you will get totally 0. So finally r square minus r power 4 by 4 is our answer. I think you got it how to apply the limits. So then what is the option here? The option is r square minus r power 4 by 4. So that is third option. So I think you got it. So our time done, children. So today I will stop the session. I am ending the session. Bye bye.